Good afternoon. I am Roy Fidel Hernandez ang the third, together with Mr. Laureta and Mr. Navarro, and we will talk about electrocution. For the contents, we have the introduction, impact of electrocution, common causes of electrocution, high-risk environments, preventive measures at home, safety protocols in the workplace, electrical safety, first aid for electrocution incidents, prevention through education, legal and regulatory framework, case studies and lessons learned, empowering communities, and key takeaways. First, what is electrocution? For the definition, electrocution refers to the fatal injury or harm caused to a person or animal when they come into contact with an electric current. It often leads to severe injury or death due to the disruption of the body's natural electrical systems. To give you context, electrocution can occur in various settings, such as when a person accidentally touches a live electrical wire, encounters faulty electrical equipment, or enters water that has been electrified due to faulty wiring. Now let's talk about the importance of awareness. First, prevention of accidents, wherein awareness about electrocution risks helps individuals identify and avoid hazardous situations, reducing the likelihood of accidents. Next, we have the safety measures, wherein being aware of potential dangers encourages the use of safety equipment, such as insulated gloves and tools, and adherence to proper procedures when working with electricity. Next is prompt response. Awareness enables quick action in the event of an electrocution incident, including calling for emergency medical help and, if safe, providing basic first aid until help arrives. Next is compliance with safety regulations. Businesses and industries must be aware of and comply with safety regulations and standards to ensure a safe working environment for employees. Next is education and training. Awareness campaigns and training programs educate people about the risks associated with electricity, teaching them how to handle electrical equipment safely. Last, we have the public safety. Awareness extends beyond the workplace to homes and public spaces, reducing the risk of accidents in everyday life. Uh, this is a key takeaway to remember. Be vigilant around electrical systems and follow safety guidelines to prevent accidents and protect lives. Now let's talk about the impact of electrocution. We have the physical effects. First, we have shock. Immediate response of the body to electric current may cause muscle contractions, pain, and disorientation. Next, we have burns. Electrical burns can range from mild to severe, depending on the voltage and duration of exposure. Next is cardiac arrest. This is a severe electric shock which can disrupt the heart's natural rhythm, leading to cardiac arrest. And we have the long-term consequences, which is first, we have the neurological damage. Uh, Prolonged exposure to electrical current can result in nerve damage, affecting motor skills and sensation. Next, we have the organ damage, wherein internal organs can be affected, potentially leading to long-term health issues. Next, we have chronic pain. Some survivors of electrocution may experience chronic pain due to nerve and tissue damage. Last, we have the emotional and psychological impact, wherein there's this post-traumatic stress disorder or PTSD, wherein survivors may experience flashbacks, anxiety, and depression as a result of the traumatic event that have occurred upon them. Next, we have phobias, which is the fear of electricity, water, or specific environments as it may develop after an electrocution incident. Last, we have the loss of confidence. Individuals may experience a decrease in confidence, especially in situations involving electrical equipment. Next, we have the common causes of electrocution. First, we have direct contact with live wires. Uh, this case occurs when a person comes into direct physical contact with exposed live electrical wires. For example, touching a live wire with bare hands, using metal tools near live wires without proper insulation. Next, we have the Another cause of electrocution, we have the faulty appliances and equipment. This occurs when there is a malfunctioning or improperly maintained electrical device, which can lead to leakage of current. For example, uh, damaged plugs or appliances with exposed wiring. Next, we have damaged insulation. This occurs when the protective insulation around wires or cables deteriorates or is damaged. It increases the risk of electrical exposure. For example, worn out or chewed insulation on electrical cords. Next, we have water and electricity. Water is a conductor of electricity, and contact with it can lead to electrocution. For example, operating electrical appliances near water sources, swimming pools with faulty wiring. Yeah. Next, we have DIY electrical work. Uh, I think this is the most common, as untrained individuals tend to attempt doing electrical work without proper knowledge and safety precautions. For example, incorrect wiring connections, inadequate grounding, or overloading circuits. And how do we prevent this? How do we prevent these common causes of electrocution? First, we have regular maintenance and professional electrical work to minimize risks. And next, avoid direct contact with live wires and practice caution around water sources. Next, let's talk about the high risks environments. First, we have construction sites. Construction sites often have a high concentration of electrical equipment and wiring, increasing the risk of potential electrocution incidents. There are factors such as temporary power sources, exposed wires, and equipment in close proximity. Next, we have industrial settings. Industrial facilities house heavy machinery, complex electrical systems, and a multitude of electrical connections, making them high-risk environments. And there are existing factors such as high voltage equipment, complex electrical systems, and a variety of power sources. Next, we have water-related areas. Uh, Areas with water, such as pools, beaches, and docks, present a higher risk due to the conductivity of water and the potential for faulty wiring near water sources. Also, there are these existing factors such as wet conditions, submerged electrical systems, and proximity to water bodies. Next, we have laboratories. Laboratories often use a wide range of electrical equipment and experimental setups, making them susceptible to electrical hazards. And factors which make them high risk is uh, specialized equipment, high powered instruments, and various experimental setups. Last, we have power stations. Power stations generate and distribute large amounts of electrical energy, posing significant risks to workers and personnel. Also, there are existing factors such as high voltage equipment, transformers, and complex electrical distribution systems. And takeaway, awareness of high risk environments to enhance safety protocols, specialized training and strict adherence to safety guidelines, and regular inspections and maintenance to mitigate potential hazards. And here's Mr. Laureta to further knowledge in this topic.
Preventive measures at home. Construction sites. Use the right equipment. Double insulated tools are designed for environments with a high risk of electric shock. These safer tools have a layer of electricity resistant material along with a layer of conductive material. The combination adds a layer of protection between live wires and the operators. Know the location of nearby power lines. Before breaking ground on a project, learn where both the overhead and underground power lines are located. Inspect tools before use. Equipment wears and tear is natural, but it can become dangerous if you don't look at items prior to using them. Always check things like power cords for exposed, fried, or damaged sections. Use personal protective equipment or PPE. Add another layer of protection for your team with PPE. Safety training is always important, but it can be life-saving during dangerous tasks like working with electricity. And keep metal objects away from live electrical circuits or parts. Industrial settings. Regular inspection and maintenance of electrical equipment. Regular inspection and maintenance of electrical equipment can help identify potential hazards and prevent accidents. This includes checking for signs of wear and tear such as fried wires, loose connections, and damaged insulation. Use of proper grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for electrical current to flow safely to the ground, while bonding ensures that all metal parts of an electrical system are at the same potential. Proper use of extension cords and power strips. Improper use of extension cords and power strips can lead to electrical hazards. Use of warning signs and labels. Warning signs and labels can help alert workers and others to potential electrical hazards. These should be placed in areas where electrical hazards may exist. Electrical safety training for non-electrical workers. Electrical safety training is not only important for workers who directly work with electrical equipment, but also for non-electrical workers who may be working in the vicinity of electrical equipment. Use of non-conductive tools. When working with electrical equipment, it is important to use non-conductive tools to prevent accidental electrical contact. Non-conductive tools are made from materials that do not conduct electricity, such as fiberglass or plastic. Emergency response plan. An emergency response plan should be in place in case of an electrical accident. This plan should include procedures for responding to electrical shock, electrical fires, and other electrical emergencies. Water-related areas. Keep all electric appliances away from places where there is water, such as a sink, toilet, or bathtub. Keep electric appliances outlets and light bulbs away from flammable liquids or products that produce vapors. Make sure that all power tools are grounded or double insulated. This means there is an extra barrier between you and the electricity. Power stations. Inspect wiring of equipment before each use. Replace damaged or fried electrical cords immediately. Use safe work practices every time electrical equipment is used. Know the location and how to operate shut-off switches and/or circuit breaker spans. Use this device to shut off equipment in the event of a fire or electrocution. Limit the use of extension cords. Use only for temporary operations and then only for short periods of time. In all other cases, request installation of a new electrical outlet. Multi-plug adapters must have circuit breakers or fuses. Minimize the potential for water or chemical spills on or near electrical equipment. Laboratories. Turn off the power to equipment before inspecting it. Turn off circuit breakers or unplug the equipment. Use only tools and equipment with non-conducting handles when working with electrical devices. All current transmitting parts of any electrical devices must be enclosed. When checking an operated circuit, keep one hand either in a pocket or behind your back to avoid making a closed circuit through the body. Maintain a workspace clear of extraneous materials such as books, papers, and clothes. Avoid contacting circuits with wet hands or wet materials. Check circuits for proper grounding with respect to the power source. Do not use or store highly flammable solvents near electrical equipment. Multi-strip outlets or cube taps should not be used in place of permanently installed receptacles. If additional outlets are required, have them installed by an electrician. Safety protocols in the workplace. The GFCI is rated to trip quickly enough to prevent an electrical incident. If it is properly installed and maintained, this will happen as soon as the faulty tool is plugged in. If the grounding conductor is not intact or of low impedance, the GFCI may not trip until a person provides a path. In this case, the person will receive a shock, but the GFCI should trip so quickly that the shock will not be harmful. Regular electrical inspections. Protection against possible surges. This is a common phenomenon in different regions, especially when there is a storm. Electrical surges can not only ruin your appliance but can also create short circuits in your house. Fire. Many times it has been seen that an electrical short circuit has been the reason behind a fire breakout in a house. Shocks. Imagine touching an electronic appliance and immediately experiencing a surging electric current in your body. Although the impact may not be that disastrous, however, this could lead to other mishaps easily. Proper appliance use and maintenance. Don't overload your appliances. Every appliance has a limit on how much it can handle at once. Make sure you don't overwork it by loading too many items into it at one time. Clean regularly and use low settings when possible. Regular cleaning is essential for all our home appliances, from washing machines and refrigerators down to microwaves and dishwashers. Check for leaks and repairs. It's important to be proactive when it comes to repairing any issues with your home appliances as soon as they arise. This means checking for leaks in hoses and pipes frequently, as well as looking out for signs of wear and tear on the appliance itself. Replace old parts and components. Another key factor in extending the life of your household appliances is making sure all parts and components are up to date. Use the right settings. Knowing how and when to use each setting on your home appliance is key for getting the most out of it while also extending its lifespan. Water and electricity safety. It is also advised that you do not use electric power tools outside when it is raining, or if you are doing any job which relates to water. Never use an electrical appliances near water. Never touch anything electrical with wet hands. Never leave an electric appliance where it can fall into the water. Never leave a dangerous electrical appliance around children, and watch out for damaged electrical wiring. Child-proofing outlets. Another effective method for child-proofing electrical outlets is using outlet covers and plugs. These are various types of outlet covers and plugs available on the market, including sliding outlet covers. These covers have a sliding mechanism that automatically covers the outlet when unused. Box outlet covers. These covers encase the entire outlet, making it nearly impossible for a child to access the receptacle. Outlet plugs. These simple devices are inserted into the outlet, blocking access to the receptacle. However, adults can easily remove them when the outlet needs to be used. Keep electrical cords out of reach. Children may be tempted to pull on electrical cords, potentially causing appliances to fall or become unplugged. To prevent this, ensure all electrical cords are out of reach and secured using cord organizers or cable ties. Educate your child about electrical safety. As your children grow older, it's essential to educate them about the dangers of electrical outlets and the importance of electrical safety. Teach them never to insert objects into outlets and to avoid touching electrical cords or appliances with wet hands. Tools and equipment for electrical safety. Personal protective equipment or PPE. When using electrical PPE, it is crucial to follow best practices to ensure maximum effectiveness, safety, and ability to reduce the risk of electrical injuries by considering these key practices. For head protection, hard hats. For eye and face protection, safety glasses, face shields. For hearing protection, earplugs. For hand and arm protection, insulated gloves, rubber lineman gloves, sleeves. For foot and leg protection, safety shoes and dielectric overshoes. And for body protection, flame-resistant clothing and arc flash suits. Lockout tagout procedures. Because machines and equipment contain hazardous energy, it is important to adhere to site-specific lockout tagout procedures. Step 1 is to notify affected employees. Step 2 is to identify procedure and hazards. Step 3 is to shut down. The step requires operating machines or equipment to be shut down. This can be accomplished through normal stopping procedures like pushing a stop button. Isolate machine from energy source. That is step 4. Step 5 is to apply lockout tagout devices. Step 6 is check stored energy. Once energy isolating devices are locked out, this step requires checking for stored energy. Step 7 is to verify isolation. To verify that the equipment is disconnected from the energy source, you'll need to test it. First, check that no personnel can be exposed to the threat of an energy hazard. Then verify isolation by trying to operate it. Step 8 is to bring equipment back online. Make sure that the machine or equipment is fully reassembled. Then check that the tools have been cleared from the work area. Survey the work area, checking to see that all personnel are in safe spot or removed from the area. Verify all controls are in neutral. Remove tags and lockout devices. Inform affected personnel that the servicing or maintenance is finished and the equipment is ready for use. Proper tool use. Workers should be trained in the proper use of electrical tools they may be required to use. Workers should also be able to recognize the hazards associated with the different types of power tools and take all the safety precautions necessary. Use the right tool for the job. Inspect each tool for damage before use. Keep all tools in good condition with regular maintenance. Operate tools according to the manufacturer's instructions. Wear the proper personal protective equipment or PPE and never use a damaged tool. Take damaged tools out of service immediately. Emergency response plans. First is to cut the power. The first thing you should do in any electrical fire is cut the power to the electrical system causing the problem. You can do this by flipping the switch on your home's breaker box. Use a fire extinguisher. If you have one in your home, everyone should know how to put out an electrical fire with a fire extinguisher. If you were unable to cut the power to the source of the fire, you should only use a Class C rated fire extinguisher. Smother the fire. If you do not have a fire extinguisher on hand, you should know how to put out an electrical fire without a fire extinguisher. If the power is to the area is off, you can use either a fire blanket or water to extinguish the fire. Practice fire safety. If you cannot control the fire, exit the buildings as quickly and calmly as possible before calling the authorities. Remember to keep close to the ground to avoid smoke inhalation and stop, drop, and roll if your clothing catches on fire. Last is to call medical support and exit. Always call for medical support in the event of a fire. Even if the fire is out, smoldering objects are still able to ignite, especially if you are unable to cut the power to the source of the fire. First aid for electrocution incidents. Insulated gloves. Insulating gloves, also referred to as electrical gloves, offer personal hand protection for workers against electrical shocks when working near or on live wires, cables, and electrical equipment including substation switchgear and transformers. These are three main types of insulating gloves. First is the standard insulating gloves. Second is mechanical insulating gloves. And the last is the ASTM D120 gloves. The standard insulating gloves are rubber gloves that provide very high dielectric properties which must be used in conjunction with leather gloves. The second is enhance the impact and excellent mechanical protection against tears and punctures without requirement for protective overgloves. The last is the American Society for Testing and Materials is the world's largest source of standards, arrived at by voluntary consensus for materials and goods. Electrical tape. In terms of safety, electrical tape is designed to prevent electric shocks, particularly where two conducting surfaces are in close physical contact and exposed to the elements. The tape helps contain the electrical current by providing a layer of insulation that effectively prevents it from escaping. This means that you won't be exposed and no short circuits will occur. Lockout devices. A lockout device is a device that utilizes a positive means to hold an energy isolating device in a safe position and prevents the energization of equipment and machinery. Examples of lockout devices are padlocks, blank flanges, and bolted slip blinds. Fire extinguishers. Electrical fires need to be put out by a substance that is non-conductive, unlike the water or foam found in a Class A fire extinguishers. If employees attempt to put out an electrical fire with a water extinguisher, there is a high risk of electrocution since the water is aconductive. This is why Class C fire extinguishers exist. The substances that can be found in these types of extinguishers are monoammonium phosphate, potassium chloride, or potassium bicarbonate. Another solution to put out electrical flames would be a Class C extinguisher that contains carbon dioxide. CO2 extinguishers are great for suppressing fire because it takes the fire's oxygen source away, as well as diminishes the fire's heat since the CO2 is cold when expelled from the extinguisher. Voltage testers. Voltage testers are used to detect an electrical current in electrical outlets. Light switches, circuit breaker panels, eh, light fixtures, and other electrical components. This helps determine if the electrical components are working properly. They can also be used to tell if electrical wires and components are safe to handle. Outlet testers can tell you if there are any wiring problems with an electrical outlet, and non-contact voltage testers can safely tell if an electrical current is present without having to contact live wires or components.
Good afternoon, everyone. I am Lance Jetrick Navarro, and we'll continue the report about electrocution. Prevention through education. Uh, for immediate response steps, call 911 or your local emergency number. Uh, After or calling your emergency number, take these actions immediately while waiting for medical help. Unang-una po is to turn off the source of electricity if possible, and if not, use a dry, non-conducting object made of cardboard, plastic, or wood to move the source away from you and the injured person. Number 2 po is to begin CPR if the person shows no signs of circulation such as breathing, coughing, or movement. Ito po yung ways kung paano gawin yung CPR. Press down hard and fast at a rate of 100 to 120 compressions per minute. After 30 compressions, give 2 rescue breaths by tilting the person's head back, lifting their chin, and blowing to their mouth while pinching their nose. If an AED is available, use it as soon as possible. Number 3, try to prevent the injured person from becoming chilled. Lastly, apply a bandage, cover any burned areas with a sterile gauze bandage if available, or a clean cloth. And don't use a blanket or towel because loose fibers can stick to the burns. Legal and regulatory framework. Ito po yung ating included po here is training programs, awareness campaigns, and engaging in communities in safety initiatives. Examples of programs and campaigns. First one is the Look Up and Leave campaign. It highlights the dangers of vehicles such as tipper trucks, cranes, and tractors. Ito po yung mga nag-operating ng malapit sa mga power lines, and this will have something that can lead to electrical shock or fatal electrocution. Number 2 is the Inigo Electricity Distribution Company, or the EEDC. It has taken its awareness campaigns to schools aimed at sensitizing pupils on the dangers of misapplying electricity. Last one is the Electrical Safety Foundation, or the ESFI. It is a non-profit organization dedicated exclusively to promoting electrical safety at home and in the workplace. Case studies and lessons learned. The OSHA standards. It rules that describe the methods that employers must use to protect their employees from hazards. Number 2 is the electrical codes and regulations. It deals with electrical issues are as dynamic as the subjects they address. Compliance and accountability, the overall integrity of a law enforcement agency's evidence management operation provides an excellent litmus test for the agency's overall organizational integrity and health. Empowering communities. Real-life incidents and their impact. So dito po, depending on the length and severity, the electric shock injuries can include burns to the skin, burns to the internal tissues, electrical interference or damage, or both to the heart, which could cause the heart to stop or breathe erratically. Lessons for safety practices. First one is to disconnect completely, meaning that the electrical installation must be disconnected from live parts on all poles. Number 2 is to secure against reconnection. Number 3, verify that the installation is dead. Number 4, carry out earthing and short circuiting. And last one is to provide protection against adjacent live parts. Conclusion. Promoting a culture of safety, proper precautions and first aid, encouraging reporting and communication, or as we say, visual communication. Ang sample po nito ay mga warning signs, warning labels, lockout, tagout, and PPE instruction, or the personal protective or protection equipment instructions. And supporting victims and their families. First one is to immediate medical attention is important to prevent severe injury and death. Number 2 is providing victims with supports to address the trauma they may have experienced as a result of the said experience. So mahalaga po yung pag-support ng victims and their families kasi po matutulungan po natin sila physically and mentally po. The collective responsibility for electrical safety, a safer future, our commitment. Thank you.